I'm really excited to speak about this topic today because I think this is a really important topic for me as well, and also, of course, of you. Before I start, I introduce myself. I'm Alexander Pester. I'm from Software IUG Professional Service. I have been working for Software IUG since 2017. Before I worked as software developer. And in the last 6 years, I was involved in various IoT projects as developer, so microservice basically, and also as solution architect. And I also I came in touch in different industries, so I worked for healthcare, for transport, manufacturing, and energy at the moment. And what I could see is that these projects getting more and more mature, and of course also complex. For that reason, I have the same slide as Jürgen had today, but it shows something really important, that the IoT projects getting more mature, but on the other side, the complexity grows. And this is what I can personally also really see at the moment. I don't want to go in details. Jürgen did this already really nice today. And to create this awareness how complex such solutions can be, I have here an example created. It's influenced by my projects I did, and this shows really, often the use cases and the architectures we see at the moment when we build an IoT solution. Of course, on the bottom, you can see the devices we have to integrate. We have usually different protocols to integrate. We have legacy devices we have to integrate. We have new devices which are usually use modern technologies like MQTT. Then we have maybe third-party devices we have to integrate. All the data, of course, flows then into Cumulocity. We use the standard tools here, in that case, cockpit and device management. We have some Apama running, and of course the data gets also offloaded in historical store and in a data lake. And what we also really see here as well is that we also have to integrate a lot of different components. So, for example, we have some contract data about your devices, and about the service technician. We have to get this data from these external systems and integrate this in the IoT platform as well, but also, of course, other way around. The IoT data must be integrated in these systems, so we have really a totally integrated solution. And what you can see here is, of course, a distributed system and a microservice architecture as well. So, and these systems are really, really complex and sometimes really difficult to handle. And if you don't do it right, then usually this happens and nothing works, because if one part breaks, the complete system, if you don't do it right, can also break. So for that reason, I'm here today, and I would like to talk about not all aspects, but of some aspects which are highlighted here. So I will talk about architecture and design, so best practices here, development, and a little bit about deployment. The other parts, the session is too short to really cover everything. But of course, the professional service, and we can, of course, always help you here with these topics as well. So let's start with the microservice architecture and design. And I picked here a few things which I think are really important to know when you start developing a microservice. And I mean, this is a really easy one, but sometimes I think customers or partners doesn't really understand what the difference is. So if you are, for example, running in a multi-tenant environment, and you can configure your microservice in two different ways. One is you can configure this in a multi-tenant isolation configuration. This means you deploy your microservice on the enterprise tenant, and you subscribe from the standard tenants, but you have only one instance. This is really important to know, because whatever you do in a multi-tenant microservice, you have always be aware that different tenants go to this instance. So you could imagine that you, for example, also create a scheduled job, running something, getting data from one system and put this to Cumulocity, and you have to do this for each tenant. you have to keep this in mind, because when this process, for example, breaks and you haven't developed this in a proper way, the other tenant will maybe not be served because the process is broken. It's just one instance. So be really aware of that, create thread pools, and be really also think on failure handling. You're only one instance. Of course, if you have a microservice per tenant, you don't have these problems, but it's of course a more expensive way to do. But if you have, of course, doing a lot of load, a lot of stuff in your processes, in your microservice, then it's probably the better way to have a per tenant microservice. If you do rarely things, then of course it's cheaper and better to have a multi-tenant microservice. Yeah, this is one aspect I wanted to highlight today. The other totally different aspect, but this is something when you start developing a microservice, you usually you expose REST APIs. This is the normal way we do at the moment. So the communication between Cumulocity and microservice is REST. And of course, also communication between microservices is usually REST. And this is currently the only way we in standardized way, we can communicate. Designing a REST API isn't as easy as most people think. So REST is, of course, a standard, but it is quite free. You can do a lot of different things. I just picked here also a few things I would like to highlight. And the robustness principle, for example, this is a really nice thing you should always keep in mind. If you consume and expose REST endpoints, so be liberal in what you accept, be conservative in what you send. Really good thing you should always keep in mind. The other really important thing is design first approach. I did this in my last 3 microservices, this approach, and this worked really out. It's really nice if you start describing your API in an open API specification. Then you can insert this to different tools, show this in a graphical interface. You can really nicely discuss this with other customers, with consumers of the API. So this is really nice. And if you have done this and the API is fixed, then you can also already start rapidly development, because you can usually also generate out of this open API specification a client or a server. I know the code is not perfect, but it's a good starting point. Then you can move the bits and you are really quickly in developing. Another good point, try to version your APIs. So put this in your path or in a header option that you really can see what version you're running on at the moment. And it makes also, if you ship different versions, you also have a backward compatibility. It's also really nice, good practice you should do. Security is also a really important part. There are also 2 aspects I would like to mention. One is in Cumulocity, if you consume the API of Cumulocity, you should always be aware, if you call the API, you can do this in 2 different contexts. If you are in a user context, you use, of course, a user which is logged in the Cumulocity, and you call this API with that user. Or you can use a microservice context, which is a technical user of the microservice. You always have to see which one is the right. In some cases, if you have a scheduled job, for example, you don't have a user context, then you have to use a microservice context, of course. And another good point, and this is what I haven't done in the past, but in the future I will always do, is putting the roles on your endpoints. So you can use standard roles, or you can at least introduce your own roles with your microservice, which is, it's not a pain, but it makes the system much more secure. And use, of course, microservice frameworks, also called chassis. They have already some patterns implemented, so pagination, circuit breaker, and all these things you might need to have a really good API. Next topic, a totally different one, is data modeling in Cumulocity. Really important one, I think. And as you have seen this already today in different presentations, and you know this is our domain model. It's really abstract, and it's of course extendable, as you probably know. We are device agnostic. We can, with this model, we can also present all verticals and use cases with extensions, you probably know. But with these extensions, I would really quote here Peter Parker's uncle with oh, I have forgotten the quote. Can someone tell it? Yeah, with great power comes great responsibility, exactly. And this is exactly what we have here as well. So we have this extensible model, which is really great, but you can do a lot of mistakes with that. And you should prevent this. So for that reason, I also have here a few best practices. Of course, there are much more, but I keep it short. When you start introducing custom fragments, use really, or build your naming conventions. Use also an information model in your company that you really have the same understanding, and that you have really a standard of your domain model. Then also look on the device management library we have. We have already a lot of standard fragments you can use, so you should not introduce your own. You should use what already exists. And this has also a big advantage. The UI will, of course, automatically show also these fragments and these properties. To inventory, Tim already said today a really important point. Keep these documents lean and flat as possible. It makes more sense to have maybe a camel case name as really a deep structure. So keep it really flat. And size matters as well. These are all adjacent documents, and if they're getting too huge, and device-managed objects are loaded really often. If they are big, you can imagine, then the load will be much slower. So if you have a lot of data, you will, anyway, to join this device, you make use of these hierarchies we have. We have child device, child assets, and child additions. You can link data which is maybe not often used, but you want to link this to the device with this relationship. Yeah, of course, again, use also the standard fragments. That is quite usual. To measurement events, there's also two things I would like to say, and Martin said this today already, which is, I mean, with a new version, we will have this performance improvements with time series. In the older versions, we don't have this, but there is a small workaround you can do if you really put all your data, if the data has the same time series and the same device, in one big measurement. So you have really a multi-series measurement. This makes the platform much better perform with this data. And really easy one. But I did this sometimes in the first beginning. Of course, if you have some enumerations or strings you want to save, you have to use events, and you can't use, of course, measurements. Measurements can only handle numbers. So that's for the design part. And now we go to microservice development. Yeah, as you probably know, we have our microservice SDK. This is written in Java, and in the past, we usually said to the customers, the partners, yeah, it would be great if you could use this, but in my opinion, we shouldn't do this anymore. We have already now built up a quite huge part of clients. I would not call them SDKs, but clients are good enough, which handle also other programming languages. And here's also a good hint and a good practice. Please choose your language you are good in and what you are familiar with, and don't choose because we have just a good microservice SDK Java. If you're not a Java developer, you are like more Python, go for Python. And of course, we have also a big community. We will also probably create more and more clients. Some of these clients are even generated by the Open API specification. They are open source. We are happy if you contribute. So we are one community. And of course, if you have such thing, you can quickly start your project. Another good point, I'm Stefan as author here. We have a lot of really, really nice resources in the internet. So we have our developer center, also our tech community. There are forums, there are the experts you can ask. There are really nice tech articles and really good knowledge. You should really use this. So if you start developing a microservice, please use that. Also on our public GitHub software AG organization, we have really nice projects with templates, with utilities. Please check out. I also contributed there 2 things really important. Is Maven archetype, so you can set up a microservice in 1 minute. It's already running. And we also created also some microservice templates. There are, for any languages, you will find some examples and what you can use there. And of course, the online documentation of Cumulocity. I know it's sometimes difficult to find something, but actually everything is in if you find it, but it's sometimes difficult to find. And the Open API specification as documentation. Really good resources, a little bit distributed, but these are the main resources I would suggest. Of course, we also have our developer portal, tech community again. And here also, Stefan is also creating some events for the developer. Yeah, I just wanted to mention. Yes, next one, general microservice best practices. Of course, there are books written about this topic. I just picked 3 of them, which I think are really important and actually also easy to do. One thing is use a microservice chassis or a framework. And I don't talk really about, yeah, of course, if you develop in Java, you will use Spring Boot. But if you use another language, and maybe there are not in typical microservice framework available, you can create your own. It's no problem. It's nothing else than a bunch of frameworks put together, which are usually useful for microservices. And this is really, it sounds easy, but you should do this also for one reason. If you have such an microservice architecture, you usually develop not just one, you develop a bunch of microservices, and maybe also your team will grow. To make this easier for the developer, please create such a microservice chassis. You can align with all of them. The onboarding is much faster. They understand what each other is doing. The code looks the same. The behavior is the same. So it's for the developers much easier if you have such a microservice chassis available. You can build this by your own. And of course, these chassis have also, of course, a lot of nice functionality. For monitoring, logging, all these things which are really important in microservice architectures. Yeah, the other things, performance, efficiency, infrastructure, abstraction, of course, this will all come. This is microservice chassis. The second one, use communication standards. Sure, I think this is not a really big issue anymore. Most people do that. But here again, describe I'm referring more to the data formats, the contracts. Describe your schemas, what data you ship. You could also version this one that the APIs are really understandable, documented, and the consumer side can also really nicely include your API. Of course, there are also a lot of patterns you should follow. I already mentioned a few, circuit breaker, and etc. for fault tolerance, retry mechanisms we always use as well. So if you have a communication between different microservices, there can of course be always some mistakes and exceptions happen. You should handle them wisely. Otherwise, we have again this boom and the complete system is not working. And security, of course, we are not talking about functional calls. We are calling functions in another network. And of course, there's security really important. If you have a machine-to-machine communication, of course, you should use the best if possible. Yeah, you can certificate, authentication, mutual certificate, authentication is the best. If you can do that, would be great. Yes, and the third one, keep microservices stateless. This is easy said, but it's sometimes really difficult to achieve, and sometimes you need functions you can't really reach that. So if it's possible, keep it stateless. You will have a lot of advantages if you can do this. But in some cases, for example, also a scheduled job, again, always the same example, you also have there in state So you are not stateless really anymore, but you have to do this, or some caches sometimes. If you use a cache because you have to store some data, because you don't want to fetch this data always again and again to have a better improvement, you need some cache data. If you persist this, it's okay, then it's still stateless, but sometimes you have a time where it's maybe not persisted, then you have a state. So if you have a stateful microservice in some cases, of course, then you have to retain the state, and then everything gets more complicated, but in some cases, you should just try to be stateless. And here I also have collected some best practices about Cumulocity. These are really just a few which came in my mind during the last projects. So the first one, know your queries in data ingestion. This was really something I learned in my last project. The Cumulocity ships with a lot of MongoDB indexes, which are great, but sometimes there is an index which is maybe not perfect for you. And we could remove this index, and then your platform gets much faster. We did this for our last customer. There was an index which was not used at all, and with that we could bring the performance of data ingestion, for example, much faster. So for that reason, it helps us a lot if you know what your queries are and your data ingestion looks like, what you will do in the future, and then we can tweak the MongoDB quite in a good way. Again, small and lean and flat documents. I don't have to say this again. We heard this today a lot. This makes querying and also data ingestion and also for the data better to process these documents. Then we also have this processing mode. I haven't used this much, but actually this is also quite a nice feature. For example, if you have high-frequency data which is flowing in the Cumulocity and you don't want to persist them, you just want to get this to the real-time channel, Apama is analyzing this data and aggregates something, and you store only a fraction of this data, then of course this makes the performance of the Cumulocity also better. This one is actually also a bit a bad practice, but I just want to mention here because also Martin is currently working on that. But at the moment, if you have an view in your Cumulocity where you combine device data plus current data of your measurements, we usually store this on the managed object then. This is the only way currently we can reflect this in the UI. But you have to be careful. It's a good practice to do that, to see the data. But if you do the updates of the managed objects too often, so if you have high-frequency data coming in and you update your managed objects really high frequently, you have to be really careful with that. But Martin is working on this topic. Hopefully, we don't have to do this in the future anymore, and then the product is really good. Yes, keep device alive. This is something we often use when you have a device and you use online and offline functionality of Cumulocity and you don't send regular measurements, then you do an empty put on the managed object. This is also a little bit of workaround, but a good one. It's working, and we do this quite often. And fire and forget, this is also possible. So if you want to upload a lot of measurements in a really huge list in a bulk, then you are not interested in the response. So you can also do that, really. You just send the measurement list, and you don't want to get anything back, so you save a little bit traffic on the internet. And measurements with multi-series, I already said, and Martin already said this. Maybe I'm not sure if this is maybe not possible not necessary anymore with a new time series feature. I'm not sure, but we still do this. All right. Okay. Now some words about microservice deployment. And yesterday I also attended the hackathon. I'm not sure Ruben is not here. Unfortunately not. And I did yesterday, I played around with exactly this tool, and I can really tell you this is a really great tool and you should use it. And you probably know that the answer of all questions is 23, but this is really the answer for all Cumulocity questions is the go, CLI. So I can really recommend you to use this tool. It's really useful in any phase, actually. I use it sometimes to analyze data, to do some automatic jobs on data. And what exactly is this tool? This is a command line interface, and this abstracts the API in a command way. And you can, in addition, you can use all the command line typical nice features like pipes, and you can even extend this. And this is exactly what I did yesterday. I extended this tool with an UPCOA REST API command. So I can now create, for example, a connection between an UPCOA, so the agent, the gateway, and the UPCOA server with a command, which is great, which is easy to use. And now I can even use pipelines. I could now select all my UPCOA servers and connect to another gateway or something like this. This is, I mean, that's not useful, but you could do this now. And this is really great. And what I actually wanted to mention is that this is a great tool also for pipelines. So you have maybe GitHub Actions you use. This is really the way to go. Then you can really just write a comment to set up your tenant options, to configure your platform, to do some integration tests. You can do everything. It reflects really the complete Cumulocity API in a great way. So I really recommend to do that. I'm still working. I'm a big fan of this tool, so that's just I wanted to mention. All right, and the next topic, totally different one, and this is something I learned in my last project. Charles is not here. It was the Enercon project. We did this in that way, and this the deployment strategies of microservices. Usually in all the professional service projects, we have this typical three types environment. We have development, test, and production. I mean, this is a good way, and this is the standard way we will always do. We do also by Enercon. But in the Enercon project, we had a problem because the test system was difficult to get in a real production shape. I mean, it's expensive. This is a huge fleet. We have different devices, and to simulate such things is really, really difficult. We had features we couldn't test. This was the problem. And for that reason, we choose two different strategies as well. So you probably already heard today also feature, flag, or toggle. We use that. We introduce features which we can enable and disable. This is really nice, for example, also for if you have two different microservices which have a different version currently deployed on the production, and you have to disable this feature because it's not enabled on the other one. And it's also a controlled risk. For example, you have a feature which is, you have to ship really fast to our production site, and it's failing, then you have to quickly switch off without rolling back everything. This is also possible, so you have a controlled risk. And another one, which was pretty new to me, is the Canary deployment, side-by-side deployment. So what you do there, you select a group of systems or a group of users which are actually the beta testers. And of course, this has also an influence on your microservice, how to build them. But if you do it right, you can do that. And for Enercon, we selected a small fleet for our beta microservices. And there, we can really quickly test things which we are not able to test on test system, for example. And we get really quick feedback from the customers. And we implemented 3 of them, and we are working well with that, I think. Yeah, and last but not least, I'm from professional service, and if you as customer or partner have problems with microservice architecture, or you need some good practices, we are happy to help you. We have there in service. We offer there in service. It's really easy to digest. An expert is coming to you, helping you with different aspects and problems you have. I mean, from professional service, we were involved in a lot of IoT projects, and so we have a lot of experience as well, and of course with the platform. Yeah, so find out on the internet site. There's fast track services you can find, and this is a new one we also offer to you. And this is just, maybe you can pick, here I have just collected all the links. If you want to have these links directly as email, you can also send an email to me. I can just give you the links. Well, that's it from my side. Thank you.
Any questions here? We have Alexander, you came in well ahead of time. We are now ahead of schedule, which is good. Any questions?
Hi. Yeah, you explained that in the Enercon use case, you had challenges testing features and software because of the amount of devices. How many devices you were talking about? Like
it's not the amount actually, but it's the diversity of devices. So we have currently 90,000 devices onboarded. So these are these turbines. And there are, of course, also use cases which are difficult to simulate. There are error codes we have to handle and all these things, and this is sometimes really difficult to have it in use or to simulate this really strange behaviors of such a turbine, for example. So there are different aspects, and we have, of course, also sometimes things we can't simulate. I mean, we are creating a simulator at the moment, but there was no possibility to change a parameter, for example, something like that, or we had to cover an error code and a parameter change, and the test cases were sometimes really, really complicated.
Because of the complex environment.
Yes, exactly. Yeah.
Okay, thank you.
You're welcome.
Still have one question. So when it comes to creating new microservices, so for example, you have a new requirement, you want to create a microservice for that. For you, from your experience, how do you decide whether you extend the microservice, existing one, or you go with the new one? Because maybe the new requirement is, the microservice will be too small, you know what I mean?
Yeah, this is always a really good question and really depends. So from my perspective, a microservice should only handle one domain. So if you have, for example, a microservice which is handling contracts. You want to create a contract, you will list all your contracts, you have to do something with your contract, then it should be the contract microservice, and you should not put there a billing mechanism inside. So I would always slice a microservice really in a specific domain. And this should also be reflected in the API. Actually, and this is what we sometimes not do, is that also the domain of a microservice should be really isolated. The domain model, only the microservice is describing this, and the other one is describing another domain. And I would always go for this approach, slices. But of course, sometimes there are also other aspects. I mean, if you have more microservices, small ones, it's getting more complex. So if you have a small team, then sometimes also good to say, okay, we put everything in one. So it really depends.
So basically, group them based on their, so to say, the feature that they're providing, right? Even though maybe they're slightly different.
Yeah, sure. Depends also on your resources and on your team size.